In this lesson, we will learn about multiplying matrices together. This is a process that's also known as finding the dot products of two matrices. So here we go. Before we go any further, go get a pencil and paper. Watching me do this is not going to help you nearly as much as doing it yourself. There are a lot of numbers, and it gets very complicated if you're just following along by watching. If you are actually writing them down, pausing the video, and making sure that you understand where each element comes from, you'll be much better off. So go get a pencil and paper, and then hit play once you get that. Now, multiplying two matrices isn't as simple as multiplying a matrix by a scalar value. Two matrices being multiplied by each other, each row of the left matrix, or the one on the left-hand side, will be multiplied by each column on the right-hand side. And the result of this will involve you adding together, multiplying certain elements, and then adding them together in order to come up with one single element in the product matrix. So I think it's easiest to understand this by looking at an example. So we are going to multiply the first row of the left matrix by the first column of the right matrix. So the 1 and the 5 correspond with each other in this case, and we'll multiply them together. 1 times 5. The 2 will be multiplied by the 7, because remember, row times column. So the 2 and the 7 will match up. 2 times 7. And then when we find each of those individual products, we will add them together. So 1 times 5 is 5, plus 2 times 7, which is 14. 5 plus 14 is 19. Okay, first row times the second column. Now this will give us our top right, because that's the common location. So the 2 and the 6 kind of have the same location. So this will give us our top right value when we finish. So 1 times 6 plus 2 times 8. 1 times 6 plus 2 times 8. 1 times 6 is 6. 2 times 8 is 16. 16 plus 6 is 22. Now the bottom row, 3 and 4, will be multiplied by each of the columns. So 3 and 4 times 5 and 7. 3 times 5, 4 times 7. 3 times 5 is 15, plus 4 times 7, which is 28. 15 plus 28 is 43. And finally, 3 and 4 times 6 and 8. This will give us our bottom right value. So 3 times 6 and 4 times 8. And 3 times 6 is 18. 4 times 8 is 32. Add those together, and you get 50. Now, when you look at this, I want you to notice some sort of patterns. For example, the first row here, 1 and 2, that is, the 1 and 2 end up just in the tops of our work matrix in the middle. 3 and the 4 end up in the bottom. So there's like a pattern involved with that. Also, the first column, the 5 and the 7 from this column, are only in these two values. And the 6 and 8, the right, are only in these two values. See, 6 and 8, 6 and 8. So when you set this all up and you look at like the work matrix that you do in the middle, that you kind of show what everything multiplied by, you should notice that these patterns, and there is a repetition to it. And as we get to larger matrices, 3x3s and so on, it's more important that you identify that certain patterns take place in your work matrix. Here's a much larger example that we're not actually going to do out. I made a matrix with all variables on the left side and numbers on the right side, just so you can see how everything kind of matches up and goes together, and to notice that, hey, there are some patterns involved with this. So ABC is the first row, and that will be multiplied by the first column. So A, B, and C, there they are. And then the first column, 2, 5, and 8, 2, 5, and 8. They match up, they correspond with each other. Everything is great about that. Of course, we can't multiply this out because A, B, and C don't have any numerical values that we know of at this point, but those will be the things that get multiplied, and then together they're added together, and that gives you one single result for that element of the answer matrix. Also notice A, B, and C, because it's the first row, it is in every single top product. D, E, F is in every single middle product, and GHI is in every single bottom product. And in the columns, the leftmost column of our solutions, all are being multiplied by 2, 5, and 8. 2, 5, and 8. The middle ones are all being multiplied by 3, 6, and 9. 3, 6, 9. There you go. And then 4, 7, 10 for the rightmost column. 4, 7, and 10. So by doing this, we're actually multiplying every row here by each and every column here, and all of them just correspond with one element in the answer. Now, every matrix can't be multiplied by any other matrix. There has to be certain criteria that are met. So for example, we have a 2 by 3 matrix here, and that could be multiplied by a 3 by 3, as you can see here, or a 3 by 2, or a 3 by 1 matrix, or a 3 by 4, or a 3 by 8, but not another 2 by 3 matrix. Because the number of columns of the first matrix has to be the same as the number of rows of the second matrix. Otherwise, we wouldn't have everything that would match up with each other. So here, a 2 by 3 matrix can be multiplied by 3 by 3, because this row would go by this column, and this column. And then on the bottom, this row would be multiplied by this column, and this column. And that's how we get all of these answers. So 2, 3, and 4 can be multiplied by the first column, A, D, and G, A, D, and G. 2, 3, and 4 can be multiplied by the second column, B, E, and H, B, E, and H. And the top row can be multiplied by the third column, C, F, and I. And below that, 5, 6, 7 can be multiplied by this, 5, 6, 7 times this, and 5, 6, 7 times this for the last one. So that totally works out. But if we didn't have 3 rows in this second matrix right here, if we only had 2 rows, for example, this would only get multiplied by 2 numbers. We'd have 3 numbers times 2. It wouldn't work out. So let's look at that a little bit deeper. So we know that the number of columns in the first matrix has to be the same as the number of rows in the second matrix. And I like to kind of write it out like this. If you have a 3 by 4 matrix and a 4 by 7 matrix, these 2 numbers right here have to be the same. And as long as they're the same, no matter what number they are, as long as they're the same, the 2 matrices can be multiplied by each other. Now, what kind of results you get will be controlled by the other 2. If you have 3 rows in the first matrix and 7 columns in the 7 matrix, that means that your output or your solution matrix will be a 3 by 7. It will actually be a larger matrix, 3 rows, 7 entries. As long as these 2 middle numbers are 4 by 4, the output will be the other 2 numbers, 3 by 7. Pretty cool, right? All right, let's see how this works with a simpler one. So here you have 2 matrices, and it doesn't look like they actually will be able to be multiplied by each other. So the first one has 3 rows and 2 columns. The second matrix has 2 rows and 1 column. So these actually can be multiplied by each other because look, the 2s are the same. What will our resulting matrix be? It will be a 3 by 1 matrix. So how will this actually end up working out? We know we're going to have a 3 by 1 matrix, and that's a matrix that will look like this. There'll be like 1 here, 1 here, 1 here, and it will only go 1 column deep. So that's what our solution will be. So how do we fill that out? So the first row, 1 and -4, times the first column, 2 and -1. So 1 times 2 plus -4 times -1. And that will be our first result. The next one will be -2 and 3 times the same column, 2 and 1. So -2 times 2 plus 3 times -1. And our last one will be the 0 and 7 times 2 -1. So 0 times 2 plus 7 times -1. And you'll notice every number in the parentheses is from the second column, so they're all the same in each of the terms, and what I changed is the first number in them. So now we can find the products of each of these and come up with the solutions. So let's multiply these out. 1 times 2 is 2. So 2 plus -4 times -1 is +4. And then -2 times 2 is -4. And 3 times -1 is -3. 0 times 2 is 0. 7 times -1 is -7. And if we now just add or subtract these together, we'd have 6 on top. -4 minus 3 is -7. And 0 minus 7 is -7. This is the product of our two matrices. And it is a 3x1. 3 rows, 1 column. The best way to understand multiplying matrices is to multiply a few of them out, and that is what we have planned next. So now we will start working on Unit 11, Practice 2. So see you there.